You can solve a system of linear inequalities by graphing. Recall that when the variables of a linear inequality represent real numbers, a graphed solution consists of a half plane and possibly its boundary line. Thus, for two inequalities, the solution is the overlap of the two half planes. Take note of this inequality graphed here. Y is greater than or equal to 1. Because it's greater than or equal to 1, we have a solid line, meaning we're including the points on that boundary line as solutions, and then shaded above. The half plane above the line represents all the values of y that are greater than or equal to 1. It's worth noting that every point in the shaded region is a solution of the inequality. Here's a second inequality. X is greater than -3. A dashed line indicates that values on the line are not solutions of the inequality, and this one's shaded to the right to indicate the values of x that are greater than -3. Every point in this shaded region is a solution of this inequality. Now consider the system of the two inequalities graphed simultaneously here on the same plane. Together, the boundary lines create four different regions. Notice one of the regions is not shaded at all, meaning that values in that region are not a solution of either inequality. Two different regions are each shaded one time, meaning that they're solutions of one of the inequalities, but not the other. And the fourth region is shaded twice. That means that every point in that region is a solution of the system. It satisfies both inequalities. Problem 2. Solving a system by graphing. What is the solution of the system of inequalities? 2x minus y is greater than or equal to -3, and y is greater than or equal to -1/2 x plus 1. First, graph each inequality. We'll rewrite the inequality 2x minus y is greater than or equal to -3 in slope-intercept form to help with graphing, and that will become y is less than or equal to 2x plus 3. The overlap is the solution of the system. Well, first graphing y is less than or equal to 2x plus 3, as shown here. We have a solid boundary line here in blue, and we shade the half plane below the line because we're talking about values of y less than or equal to the expression. Next, we'll graph the inequality y is greater than or equal to -1/2 x plus 1. Again, a solid boundary line, and this time we're shading above the boundary line to indicate the solutions of y greater than or equal to the expression. Considering both graphs simultaneously, we can see that we have four regions created, one of which contains points that solve neither inequality. Two of the regions, the yellow one above and the greenish colored one below, points in each of those regions solve one of the inequalities but not the other. And then finally, the overlap of shaded regions on the top right indicate solutions to both inequalities, so solutions of the system. And it's a very good idea to check our shaded region. We can pick a point in the overlap region at the top right, such as 0, 2. It's a good idea to choose integers or whole numbers when possible to make the arithmetic easier. But then we want to check that in both inequalities of the system. Remember, our point has to work in both inequalities to be a solution of the system. First, the inequality 2x minus y is greater than or equal to -3. Substitute 0 for x, 2 for y, and simplify. We find -2 is greater than or equal to -3. That's true, so our solution works for that inequality. Next, we'll check y is greater than or equal to 1/2 x plus 1. Substitute 2 again for y, 0 for x, and simplify. 2 is greater than or equal to 1. Also true, so our solution, our shaded region, checks out, at least for this point, but that's a good indicator that we've done our work correctly. Your turn. What is the solution of the system of inequalities? X plus 2y is less than or equal to 4, and y is greater than or equal to -x minus 1.